Have you ever opened a Cambridge mathematics past paper and felt completely paralyzed by a massive wall of data staring back at you? Trust me, you're definitely not alone. We live in a world and face exams that are absolutely drowning in numbers. But here's the secret to hitting those top grade boundaries. Numbers alone don't tell the story, and examiners know it. It's how we visualize them that brings the truth to light. Today in this explainer, we're going to completely transform how you look at data. We are building your ultimate data interpreter's toolkit by mastering statistical diagrams. In your exam, there's zero margin for error. Every calculation and every plot must be perfect for launch. We aren't just going to treat these as boring mathematical chores, but as absolutely essential, powerful tools to decode the questions in front of you. Let's get into it. Here is our clear roadmap for today's mission. First up, categorical data. Then we'll tackle proportions and pie charts, move on to spotting trends, dive into tracking cumulative frequency, and finally, the big one, mastering histograms. All right, Section 1, Visualizing Categorical Data, Bar Charts and Pictograms. So when you just need to count things in distinct categories, things like eye colors, days of the week, or favorite devices, you want a visual that is instantly readable. Enter the pictogram. A pictogram is exactly what it sounds like, a diagram that uses pictures or symbols to represent quantities of data. But there is a massive trap here that costs students marks all the time. A single symbol almost never just represents one single unit. You absolutely must check the key before you do anything else. Okay, let's dive into this exact survey of favorite MP3 player colors. Look closely at the key right there at the top. One full red circle represents exactly 2 people. So if we look at the row for blue, we don't just count the symbols and say, oh, 6.5 people. No way. We count 6 full circles, that's 12 people, and then we see half a symbol. Since a full circle is 2 people, half a circle represents 1 person. Add that up, and we know exactly 13 people chose blue. It's a beautifully simple way to visualize volume at a glance. By the way, before we continue building this toolkit, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Proportions in Pie Charts. Now, what if we don't just care about the raw numbers, but we actually want to understand how each category compares to the whole? That, my friends, is where pie charts come in. The absolute key thing to remember here, and examiners love testing this, is that the sectors of a pie chart show proportions, not actual numbers. To draw a pie chart perfectly, you can't just guess. Zero margin for error, remember? The angle of every single sector must be strictly proportional to its frequency. Here are your foolproof steps. Step 1, find the absolute total number of items in your entire data set. Step 2, divide your specific group's frequency by that total to get a fraction. And finally, Step 3, because a full circle is exactly 360 degrees, you multiply that fraction by 360. Notice how cleanly the math works out in this example. We've got a survey of 20 students and their preferred mathematics topics. Let's look at the number topic right there. 8 students chose it out of a total of 20. So we literally just take 8, divide it by 20, and multiply it by 360 degrees. That calculation gives us exactly 144 degrees. You repeat this exact same process for algebra, geometry, and handling data. And here's your built-in exam safety check. Before you even think about picking up a protractor, all your calculated angles must perfectly add up to 360 degrees. If they don't, stop. You've made a miscalculation somewhere, so go back and fix it. All right, let's step it up. Section 3, Spotting Trends, Scatter Diagrams. Often in these exams, we want to know if one thing directly affects another. Does a car's engine size affect its fuel consumption? Do taller giraffes weigh more? We use scatter diagrams to answer these exact questions by plotting pairs of values to reveal correlation, which honestly is just a fancy mathematical word for relationship. Look at these 2 sets of graphs. On the left, as one quantity increases, the other increases, and the points are clustered super tightly together in a line. That is a strong positive correlation. On the right, you see a weak negative correlation, where the points sort of drift downwards but are way more scattered. And right below that, a complete cloud of points. When they are totally scattered like that with no clear pattern, there is absolutely zero correlation between the 2 quantities. Now, when you do have a correlation, you can draw what we call a line of best fit. This is a straight line drawn by eye that goes in the general direction of the points, keeping an equal number of points roughly balanced on each side. We use this powerful line to estimate missing values, but a massive, massive word of warning here. You can only reliably estimate values that fall strictly within the range of your existing data. If you try to extend the line way past your plotted points to make a guess, your estimate becomes totally unreliable, and examiners will penalize you for it. Hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's keep this momentum going. Section 4, Tracking Cumulative Frequency. Okay, so what do you do when dealing with a massive set of continuous data, like the heights of 60 different plants or the finish times of 200 runners? Plotting every single point is absolute chaos. Instead, we use cumulative frequency. It is essentially just a running total. Instead of asking, hey, how many plants are between 30 and 40 centimeters tall, we ask, how many plants are 40 centimeters or shorter? We calculate this by simply adding the frequency of the current group to the total of all the frequencies of the groups that came before it. It's an accumulation of data up to a specific boundary. And this brilliantly illustrates the result. Once you have those running totals, you plot them on a graph. But notice exactly where they are plotted. Always at the upper value of each interval. Do not plot them in the middle. When you join these points together with a smooth curve, you get this incredibly distinctive S-shaped curve. This curve is an absolute goldmine of information in an exam because it allows us to instantly find the median and the spread of our data without doing any complex algebra. From that beautiful S-curve, we can easily find 2 vital statistics. The first is the median, also known as the 50th percentile. If you have 60 plants, you literally just look at the 30th plant on the y-axis, draw a straight line right to the curve, and drop down to the x-axis to find the median height. Boom. But the median only tells us the middle. We also want to know how spread out the data is. For that, we use the interquartile range, or IQR. You find the upper quartile, that's the 75th percentile, and subtract the lower quartile, the 25th percentile. This gives you the spread of the middle 50% of your data, completely ignoring any extreme outliers at the very top or bottom. It's a hugely important concept to grasp. Finally, the boss level. Section 5, Mastering Histograms. Histograms are the final and perhaps most heavily misunderstood tool in our toolkit. At first glance, they look exactly like bar charts, but I assure you they operate under entirely different rules. Histograms are specifically designed for continuous grouped data, where the groups or class widths are not all the same size. Think about it. If you have an age group spanning 5 years and another spanning 20 years, a simple bar height would be incredibly misleading. A taller bar might just represent a wider age gap, not a denser population. So the absolutely crucial point is this formula. Frequency density equals frequency divided by class width. Memorize it. In a histogram, we never plot the raw frequency on the vertical axis. We plot the frequency density. Check this out. Notice how the vertical axis is distinctly labeled frequency density and how the bars are all completely different widths. Because we used our formula, the actual frequency of each group is no longer represented by the height of the bar. It is represented by the area of the bar. Let me say that again. Area equals frequency. If you multiply the height, which is frequency density, by the width, which is the class width, you get the frequency back. It is a completely brilliant way to visually compare unequally sized groups accurately. Nail this and you're securing top marks. Let's quickly recap the incredible toolkit you've just built. You now know exactly when to deploy each mathematical diagram for maximum marks. Use bar charts and pictograms for simple categorical counts. Deploy pie charts when you need to highlight proportions of a whole. Switch to scatter diagrams to prove or disprove relationships between 2 variables. Draw a cumulative frequency curve to easily find medians and quartiles for large datasets. And finally, bring out the histogram to accurately represent continuous data with varying group sizes. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the exams. Your Cambridge success starts here. And remember, you are no longer just a passive consumer of information. You have the tools to interpret the data for yourself. So I'll leave you with this. The next time a past paper, a politician, or a report flashes a chart on a screen, pause. Look at the axes, look at the key. Ask yourself, which diagram did they choose from the toolkit? And more importantly, what story are the numbers really telling you? Thanks for joining me on this explainer, and keep questioning the data.